Hello, I'm Michael Wybrow, and in this video I'm going to talk to you and show you some examples of how we can parse JSON that's returned to us from a web service. So, we saw a slide like this in the last video. This is us accessing some web service that contains JSON. We're getting a result back. It will be in JSON format. Where that will be contained is in this data value here. And we're going to say do something with it, which is this yellow part, which is what we'll talk about in this video. And then when we're done, we're going to update the UI. All right, so if we've got JSON, we can easily take those objects and pass them using JSON serialization. And this is a class that will return a value of type any, or it throws an error if the data couldn't be parsed. And then if we know the structure, we can cast that returned value, the any value, to something more specific. So for example, if we know that the JSON result that's returned, like when we were looking at some JSON in a previous video, we can say that it's a dictionary where the keys are strings and then there's a range of different values, or we can say it's an array of any type, or we could say it's something more specific like it returns an array of strings. So this is JSON serialization. You'll see parsing data the manual way. I wanted to show you this is possible, but I wouldn't recommend it, and you'll see there's quite a lot of work that's required here. How this works is, first of all, we pass in the data, and this is just the data value we were looking at before that came from the web service. We ask it to do JSON serialization on it. It returns us an any object, and this is code that can throw. So you see it has a try block, a try keyword, but instead of saying try, it says try question mark, and this means something different. When we use try in a do catch block, it is caught, the error is caught, and we jump to the catch block. Here, the try question mark means that it tries this, and if this thing throws an error, all that happens is that it assigns the value nil to JSON root. So it basically turns the use of try into an optional, right? So this thing can now return any or an optional. So the next thing we do is we try and cast our JSON root to be a dictionary with the key string and the value any. And we do this as part of optional binding here, where we say let dictionary. That might fail. If it fails, then we could have some error case down here as an else. Assuming it succeeds, we create some intermediate object, some structure or class instance, and then we can ask the dictionary for a particular property, and we can try casting it to the value we think it should have. In this case, a string, a string, a string, a string, and an int. And then once we've done that, we have an object that we can use in our code. So what is this object here, this mtg set data thing? This is just a structure with a bunch of properties. Now, if you were going to use the previous example, you would only need the structure itself and the 5 variables here. But we can make use of Codable, like we talked about last week. And Codable is all about serializing and deserializing objects, and this can make the process a lot easier for us. So if we've got a particular structure that we want to read from JSON, we can have it adopt this Codable protocol. By default, if you're happy that your JSON equivalent of this has all of the same property names and same property types, that's all you need to do. Just add the Codable keyword. If you want to override the behavior of how it does the parsing and the serialization, then you can provide extra additional information like the coding keys here. So in our example here, we have some JSON that's returned. This is the same kind of structure that's shown in our JSON pretty print. And in our structure we're going to use in our Swift code, we wanted to have a property called block name, but in the JSON that's returned to us, it's just called block, which is what's written here. So we can do that mapping by saying we have a case block name that matches our property, but the equivalent in the JSON when it gets serialized or decoded from it is going to be block. And we have the same thing here for something we're calling set size, but in the JSON it's called base set size. And you'll see in the lab class we'll go into some other examples of what we can do in terms of customizing the use of Codable. Assuming we've done Codable here, we've got our coding keys to map variable names. Once we've done this, generating objects from JSON is actually really simple. We basically do this. We create an instance of a JSON decoder. We give it some data and we tell it to decode. The other thing you need to give it is you need to give it the object, the structure and the class that you're decoding into. So in this case, we see that the top level thing is an object with 19 properties. We're just using 5 of those properties. So the thing that's been given to us is this object, and we can specify it here by just giving the self property of this particular class. If instead the JSON returned us an array of these objects, all we would do is put brackets around the mtg set data here and then do .self, and it would decode it into an array of these objects. So it's quite powerful. Once you've done that, that's it. You've got now an object here that will be an instance of the class, and the decoder will have produced that for you. And if there's any kind of error, you'll be able to see an error message of how this process failed. And we'll see in the lab class how we can do things like deal with optional properties that may or may not be present in the JSON. So this is super simple to use. The JSON data in our example also included a list of cards. So if we go back for a second, we can see here this object has an array with 238 cards. What about if we also wanted to decode that and have 283 card objects created for us? Well, this is where the power of Codable comes in. We can create a card data object. Again, it needs to be codable. In this case, we just care about 4 different properties, and we have the coding keys. In this case, we can actually even omit this part because we don't create any specialized mapping. And then there's only one small change that we need to make to our mtg set data class, and that is we just tell it that there's an additional property we care about in the JSON. It's called cards, and the structure of it is an array of this custom codable object we've done. And by doing that, we can just run our decoder, and it will create us one of these set data objects, and it will have an array with the 283 cards as part of it. So this is super powerful, and we'll see more about this in the labs. Thanks for watching.